Okay, this is section 6.2, where this is day one, where we're multiplying radical expressions. And as you look at examples here and we go through these, you're going to find out that they're not that terribly different. But the one thing that we do need to make sure we talk about is if we multiply radicals, okay, the root or the index has to be the same. So for example, you see here in this example here, if I have a square root of 2 times the square root of 3, that's the same thing as saying the square root of 2 times 3 together is 1. As long as these numbers, these indexes are the same, we can do that. Same thing here. The cube root of 4 times the cube root of 5 is the cube root of 4 times 5. I can combine those together into one root. All right. So, but the key here is it has to be the roots that are the same. So for example, if I happen to have the square root of 3 times the cube root of 2, I cannot combine those in the same root. They have to stay separate. Okay? So when we're multiplying, they have to be the same root in order to multiply. Okay, so now that being said, let's take a look at some of these examples and how we're going to do these. These are going to be not that much different from what you did when you were breaking down and simplifying. Okay? All right, so the first thing you got to make sure is you want to make sure that your roots are the same. So in this case, I have a square root and I have a square root. These roots are the same thing. So the very first thing I'm going to do is I'm going to go ahead and multiply these two things on the inside. So this is going to be the square root of 6 times 2. And matter of fact, let's do it this way. Let's go 6 times x times 2 times x cubed. I'm going to combine all these guys together. So now, the one thing as you look at these, I'm going to not multiply together the numbers. So I'm going to leave it as, for right now, 6 times 2. But I am going to, when I multiply these variables, this is where your exponent rules come in. I have an x to the first times an x to the third. That's going to be an x to the fourth. Okay? So, now, as I look at this, what I want to do now is I want to look at the numbers in here and see, can I break them down? Like, for example, this 2, can I break it down? Well, I'm going to write this down over here as 6 times 2. I can't break down the 2, so I'm going to circle it. I can break down the 6 into a 3 and a 2. Okay? Now, some might ask, well, why don't you just multiply 6 times 2 together and get 12 and then break it down? You could do that. But the problem is, when we start getting into bigger numbers, you multiplying 15 times 35. Well, there's no sense in multiplying those two together because you're going to get the same, you're going to end up having to try to break down a really big number. Okay? So now, instead of 6 times 2, what I'm going to do now, again, I want powers of 2. So I've got a 2 squared, and I've got a 3. Then I've got an x squared and an x squared. From here, it's no different than what we just did with simplifying. Okay, the whole key is to get powers of 2 in this problem because we have an index of 2. So again, as I look at this here, I got to figure out, all right, 2, that 2 comes outside, it's got a power of 2. 3 stays inside, doesn't have a power of 2. X goes outside, it's got a power of 2, that's got a power of 2, that goes outside. So now my final answer would be 2 times x squared and the square root of 3. Okay, so it's very similar to what we were looking at with simplifying. Essentially, we're just going to add a step. Okay, so now we've got cube roots in example number 2. Okay, example number 2 now. Again, I have a cube root here and a cube root here. So I'm going to multiply these guys together. So again, I've got a cube root, and I'm going to leave them separate, 9 times 36. But I'm going to go ahead and add my x's. So it's going to be x to the 5th power. Okay? All right, so now I've got 9 times 36 that I'm going to break down. 9 goes to 3 and 3. 36 goes to 6 and 6. And then 6 goes to 3 and 2. And 3 and 2. Okay, now again, key here is this time I want powers of 3. So I have, as I'm counting over here, 1, 2, 3, 4 threes. I don't want 3 to the 4th. I'm going to write this as 3 to the 3rd times 3 to the 1st. 2s, I've got 2 2s. So I got 2 to the 2nd. Then I'm going to look at my x's. I want x's to be to the 3rd power, so I want an x to the 3rd. And if I take an x to the 3rd, what's left over? An x to the 2nd. Again, if I add those exponents, I get 5 to make sure that I have x to the 5th. Okay, now again, from here, it's the exact same. Powers of 3 come out. Non-powers of 3 stay in. This guy is going to come out. That 3 is. This 3 right here is going to stay in. Doesn't have a power of 3. This 2 stays in. 2 squared. Doesn't have a power of 3. That x has a power of 3. It goes out. And that x squared does not have a power of 3, so it stays in. Okay, so now I got to clean it up. 3x on the outside times the cube root of 2 squared is 4. And 4 times 3 is 12. And then I have an x squared. That is your simplified answer. Okay, one last example here. Let's go through example number 4. Number 3 is very similar to number 2, so I want to go through number 4 here. All right, you'll notice again, this one has a 4th root. So I want all powers of 4. But before I do that, what I'm going to do, go ahead and make it all one root because they're all 4th roots. So it's going to be 8 times 192. And then I'm going to go ahead and, since these are both the same as the index, I'm going to leave them separate. P to the 4th and P to the 4th. Because I know that that's what I want is 4s. Okay, so I need to break down 8 times 192. 8 goes to 4 and 2. 4 goes to 2 and 2. Okay. 192 goes to 12 and 16. Okay, 12 and 16. This guy goes to 4 and 3. This guy goes to 2 and 2. And then 16 goes to 4 and 4. And 2 and 2. And 2 and 2. Okay, so now as you look here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 2s. Okay, but now I want powers of 4 here, right? So here's what I'm going to do. As I write this out, I got the 4th root of 2 to the 4th. That takes care of 4 of these guys. Those 3 right there and that guy. Times 2 to the 4th. That guy. 2, 3, and 4. And then I have 1, 2 left over. And then I also have that 1, 3. Then I have a p to the 4th. And a p to the 4th. Okay, so now, again from here, same concept. 4s come out. Powers of 4 come out. Non-powers of 4 stay in. That guy, gonna come out. That guy, gonna come out. 2 stays in. 3 stays in. P comes out. P comes out. So at the end here, my final answer, 2 times 2 is 4. I have 2 p's, so that's p squared, times the 4th root of 2 times 3 is 6. This is the simplified answer. Okay, so now you should be able to complete your 6.2 Day 1 practice problem.